So what I've done here is I've actually added the functionality to our code to both open up the subpage of each attraction, find the address and scrape the address into our database, and then make a call to the Google API to get the latitude and longitude data. And instead of coding this from scratch, I'm just going to open up our file from last week, which had the working web scraping code. And I'm just going to go through the differences in this code. Again, this is mostly adding to what we had before. So I'll just go through those changes to see how it works. So if we start at the top, the imports are all the same, except now we're importing one extra library, which is the JSON library, and that will enable us to read the JSON formatted code that Google gets back to us. And JSON is just a type of formatting to structure data. It's similar to XML formatting and other formatting options. But we need this library to easily read that data. From there, it's very similar. We have our extract data function, where before it was getting the number of reviews and the name of the site. Here I've added a bit of code to basically extract the coordinates from the website. So here I specify the base URL, that's tripadvisor.com, and I'm using that to get the URL of the sub page for the attraction. So if we go into the site and we go back to the main attraction site, what we want basically is to find the address that's linked through this text in order to go into the sub page of that attraction. So if we highlight that and go to inspect element in Google, we'll see that that's an A tag, so it's a link, and then the contents of the link is the sub page of that attraction. You see it starts with a slash and it's referencing the base URL, which is tripadvisor.com. So what I'm doing in this code is basically building a link to that sub page by combining the base URL, tripadvisor.com, with a search using Beautiful Soup as before, finding all the A's in the data. And so the data, remember, is the specific structure of this attraction, so it's just this chunk of code. So this is the first link or A tag in that chunk because it's the first line here. So what this will do is for every attraction, once I call this extract data function, it will find the address that goes to this attraction, attach it to the base URL, and then it will run this function that I've written called extract address with that website, and the output of that function will be the coordinates that I'm looking for. Okay, so if we keep going down, the next part is this additional sleep statement. So as I said before, the importance of sleeping for a second between calls to the site, we need to build in an additional sleep function here because this extract address function, as we'll see soon, will actually make a call to the website again to extract that sub website from the attraction. So we need to sleep again. You can put the sleep either within this function or right after or right before the function, just to make sure that it's doing that for every attraction and it doesn't overload their server. After that, everything is pretty similar. So we're getting the number of reviews as before. And then here I've just put an additional few lines to extract the category from that main site. So this isn't anything new. It's a very similar functionality to getting the number of reviews and the name, but I'm trying to get that category just so I can visualize that and have that in my data set as well. And down here I'm just printing out my results. And in the return function, we're actually returned a string with the results for one attraction. You can see that I've added the category as an entry. I've also added this part, which is the coordinates. And you can see here that this is the coordinates variable that I passed back from the extract address function. And that coordinates variable is basically a dictionary with the latitude key representing the latitude and the longitude key representing the longitude. And then I convert that into a string before I pass it into the return of this function. So that's pretty much it in terms of the changes to the extract data function. And the other major change is this extract address function that's called from within it. So here, this is basically redoing the process of extracting the HTML from the web page, but now with this specific URL that we got from the main website, and this represents the sub URL of the attraction. So just as before, we fetch the page using the fetch function that we wrote before. We use Beautiful Soup to convert that into a readable format. And then we do the same kind of thing that we were doing before, where we're using Beautiful Soup to find the specific bits of information about the address. So here I'm searching for the street address tag. I'm stripping that and then storing it in the street variable. Same way I'm getting the locality, which is the city, into the locality variable, and the region, which is the state, into the region variable. And then what I can do is I can actually use our same fetch command to fetch the results from Google API. So this is using, again, the URL lib2 library, just as before. First, I build the request code for the API. So I got this from the structure that we looked at up here. So I have the base, which is the call to the Google API. You see here is the address, geocoding, specified JSON format, address, and then I add in our information that we just got from the sub attraction website with the right spacing and everything to format just like their example, and then adding this tail of sensor equals false. So this builds the URL, and every space within that I have to replace with this %20, and this is just HTML formatting, just so the spaces come out right in the request. Then I'm just printing the request URL just so I can troubleshoot it if anything goes wrong, and I'm printing the actual address of the attraction. Then I use our fetch command again, now with our request URL, and this will bring back basically the results of this page, which in this case will be this data set in JSON format. Then I use the Json library to load this JSON file into this variable called decoded, and now I can use the JSON library to actually parse this decoded JSON file for the coordinates I want. And now I use that library to build a coordinates variable, which comes from this location in JSON. So JSON is a kind of tabulated data structure where I can call the structure itself and then go down, parse through the different tags. This is similar to HTML or XML. So if we go back to this file, I'll show you how it works. Basically, I start with the file and I go to results. So that's this main key, and that has this whole array. I get the first array within that, so it's these square brackets. So now I'm in here in this dictionary. Dictionaries are denoted by curly braces. Arrays are denoted by square brackets. So now I'm within that dictionary. From that dictionary, I get the contents of the geometry key. So if I go down here, here's the geometry key. So now I'm within this curly brace dictionary. And further, I get the contents of the location key. So now I'm within this curly brace dictionary, and that is what I'm actually storing in my coordinates variable, which is a two-part dictionary with lat representing the latitude and lng representing the longitude. And that's actually what I'm passing back from my function, and up here it's what I'm using to get the latitude and longitude. So that dictionary is already built within the Google's response. I'm just getting that part of it. And here I've put in exception catch, which will basically generate a blank dictionary if something in the API fails. And the API can fail for a number of reasons. Like I was saying before, you want to put in these exceptions so that when you're automatically scraping tons of data, one data point goes wrong and the whole thing doesn't crash. And then I'm printing those coordinates out and returning those coordinates back into my extract data function. So those are basically the only changes that we need to dig deeper into the site and get the coordinates of the attractions using the Google geocoding API. And those coordinates we're going to use to actually start mapping our TripAdvisor data in the next week's segment. So now if we run this code, it will start to open up the files, and you can see here now this whole process is taking longer because it's not just scraping the 30 attractions from the main site, it's going into each site and pausing 1 second between each one. And even though this takes longer, I have to stress again the importance of pausing so you don't overload their server. And this is taking more time, but potentially you can get a lot more information by digging deeper down into the website for particular sub-sites of each data point. And once we've run this, we can go into our data set. You can see here that it's added the latitude and longitude information to this data, and sometimes it fails for whatever reason, we get 0, 0, but in the grand scheme of things it's not crucial, and for most of the sites we have fairly reliable geocoded data that comes straight from Google, and it's the same location you would get if you typed in the actual address of the site into Google. So this is a brief description of APIs and one particular example of a very useful API that you might use for your data sets.